After we discuss the definition of the recursion functions, and then we look into a bad example of using recursion, now it is time for us to take a look of the good example of using a recursion. As we see before, tree. Tree is fundamental structure in computer science because it has so many different applications that we are able to use, including binary tree, binary search tree, Huffman encoding tree, binary heap, etc. Recursion. If we try to define tree in a recursive way, now you should have a good understanding of this. A tree is a root and 0 or more non-empty subtrees. So you can see that this is actually a very strong definition. By looking into 0 subtree, it indicates it's the base case scenario. Or more non-empty subtrees, this is actually the general case scenario. And that's why, after we discuss about the recursion, you should have a good understanding of how do we define the trees in a recursive way. Now, if we look into a non-recursive definition, a tree consists of a set of nodes and a set of direct edges that connect pairs of nodes. That is a connected graph without loop. So basically, this is something that we have seen before. So now, we have discussed about the recursive functions. It is a good opportunity to really look into the traversals and fully understand. In our previous lab, I have asked you guys to write the pre-order, in-order, and post-order functions, make it run on a binary search tree. And now, let's try to review these codes to see how much we are able to understand more about recursive functions. So let's pick up, say, pre-order. You see that for the pre-order function, it is defined a function provided a node. That's where we're going to look into. As long as that node is not null, then what we are going to do is print it out the node. So print out the data part, and then we run the recursive function passing the left node. And then, of course, when we see this function is called, we will walk into a recursive, build up another runtime stack, and then run the whole program. And that will going to give us a recursive fashion of how we will be able to run. Once all the left side of the part is done, try to think until this runtime state has been popped, then we will move into the right side of the tree. So this is what's happening on the pre-order. One more thing I want you guys to look into is that take a look of this code. What is the base case and what is the general case? Think about this. Inside of this code, you will see that this is saying if root is not equal to null, then we will do this code. So inside of this code, it is calling the recursive function. And therefore, this whole code is actually the general case. Then where is base case? The base case is actually hidden. The base case indicating if root equal to null. Thinking about this, if we hit a node that is null, then we are not going to do anything, and that's saying it's not going to call the recursive function anymore. So this piece of traversal code has a hidden base case scenario, and this is something very interesting. And now once you understand that, we see this slide before saying the pre-order is printed out, go to the left side, go to the right side. This time you should have a better understanding of what's really happening in back of this traversal problem. For when the root is being called, it will print it out the node and then go to the left side. So when we go to the left side, you see the runtime stack of node 2 has been created, and we will hold over here. And when the node 2 is working on the piece of the function, because it is non-null, it will print it out the node, go to the left side. So you will go to the node 4, print out the node, go to the left side. This is the time it will really travel to the left side and hit the base case because it's null, and it will not do anything. Come back, go to the right side, do nothing, come back. So you can see that when this is done, it hits the end bracket of the function. Then this runtime stack will be popped away, go back to the left side, the end of the left node 2 and go to the right side. So you will come to here, print it out the node of 5, go to left side, hit the base case, come back, go to the right side, hit the base case, finish this. So pop this runtime stack away, and then pop this runtime stack away again, so that we will be able to come back to the right side of the root. And this time it will travel to the node 3, print it out 3, go to the left side, hit the base case scenario, come back, go to the right side, print it out, go to the left side, go to the right side, and you can see this is the time we will be pop away the node 6, come back over here, pop away the node 3, come back over here, pop away the root node, and come back to the place that calls the whole tree function. So this is what's really happening in back of the recursive function. And of course, because the tree itself is defined in a recursive way, it is actually much easier to write this kind of code using recursive. Compare with the stack. If you still remember, we use stack to do a pre-order, in-order, post-order, and that requires much more efforts than simply write the code in a recursive fashion. Because of that, it is totally possible to do something much even more crazier than basic pre-order, in-order, and post-order. So take a look of this function. So I made slightly different now. I create a function called print to pre-order and provide the root node. So what this trying to do is saying that as long as it's not null, what it will do is it will print it out the node, and then you will go to the left side. Once all the left side is done, let's go to left side one more time. And when that is finished, it's time for us to go to the right side. So you can see that this code is defined in a very easy, understandable way, and it actually performs very well. Compared with the for loop version of this kind of code, it will be much easier in doing so. And therefore, let's take a look at this. For two pre-order example, saying that if we go to the node, we will print it out the value, go to the left side, go to the left side one more time, and then go to the right side. This time, because of the definition of the function, the whole picture will actually goes differently in a way that some node will call the recursive function once, some nodes will call multiple times. Let's take a look at this. When the root is called, it will print it out the root node 1, and then you will go to the left side. So that time you will go to the node 2, you will print it out the node 2, go to the left side, come here, print it out the node 4, go to the left side, there's null base case, left side one more time base case, right side base case, so that I just generate LLI immediately. Come back to node 2, this is something different now. So you see, when you come back to node 2, you will go to the node 4 one more time. So at this very moment, node 4 has been called the function one more iteration. So print out node 4 LLR one more time, come back to node 2, execute the right side, print it out of node 5 LLR. So it will come back to the root node. At this time, you see that we need to do the left node one more time. We will come to node 2, print it out, node 2, go here, print it out this one, LLR, come back, do that one more time, and come back. So go to the right side of node 5, print out 5, LLR. So you can see that because it's the repetition of what we have seen before. So 2, 4, 4, 5, I use a different color to show you that it will generate basically the same output repeatedly from the previous left node execution. And that's what's happening over here. When you come back to root, it will go to the right side. At node 3, it will print it out in node 3, go to the left side, go to the left side, go to the right side, and node 6 will be able to execute it exactly, and then we'll come back over here, finish the whole execution. The major thing I want you guys to see in this example is that you see node 1, 3, and 6 has called a function once, node 2 and 5 called twice, node 4 has called the whole function for 4 times. So that you will end up with every node will call differently in this type of the traversal problem. So here is the assignments that I want to give you guys. Basically, it's the same tree. The only difference is that I add one more output over here. So every time when a node being traveled, in the beginning, you will print it out the node itself, and you need to go to left, and then right side of the subtree. When all of these are finished, the node will be printed out one more time. So that I want you guys to be able to trace the code and then see what's really happening. Of course, some node like node 4 will be printed out so many different times. However, it's going to give you a very good practice of knowing what is happening when we have this kind of recursive function defined on a tree. The idea is very clear by looking into the piece of code. So you can see that for recursive code, the readability is actually a very nice properties in terms of the programming aspect.